All right. So up to this point, okay. Up to this point, what have we had to do with chemical formulas? We dealt with monoatomic ions, polyatomic ions, and then writing names of compounds. And then it's always been good practice that once you have the name of that compound, then do what? Add together the what? The atomic masses of that. Okay, so a little later on, we're going to go over a couple of these different types of problems and expand what the author is covering. So on page 238, 238. So where it says molar mass is on page 238. All right, so on the bottom there, it says in chapter 3, you learned that molar mass is substance equal to the mass in grams of 1 mole, or approximately that many particles. Particles are atoms, be a different way of looking at that. For example, the molar mass of pure calcium is 40.08 grams per mole. The example that we would use in class, I probably held this beaker up and said, if we put 32.06 grams of sulfur in here, we've got one what? We've got 1 mole of that substance. Just like what the author just said, if you have 40.08 grams of calcium in here, you've got 1 mole. And this mole is just a counting unit because you can't deal with or count the number of particles. It's just not possible unless you have even with an electron microscope. That'd be very difficult to do. So we calculate those, okay? And the molar mass of a compound is calculated by summing the molar mass of a compound is calculated by summing the masses of the elements present in a mole of the molecules or formula that make up that compound. Okay? So as we look over to page 239, okay, if we had 2 moles of hydrogen, and one of the aspects that when we look at that, okay, whenever you're doubling or tripling the number of moles, you're just taking that times the atomic mass. Now, that doesn't mean anything to you right now, but it will when we apply some of these examples on here. Okay, so there's some sample problems that you can look at on page 239, 240, 241, but the one in particular that we want to spend time with is on page 241. Because some of that is a review. Then in letter C, it shows what a different, what do I want to say? How do I want to say this? An extension or an addition to knowledge that you already know. That would probably be the best way of saying that. Sample problem I on page 241, because the prior examples is just a review and refresher of what you learned in chapter 3. Okay, so ibuprofen, C13H18O2, is an active ingredient, mainly non-prescription pain relievers. Okay, its molar mass is 206.31. In other words, you're taking 13 times 12, 18 times 18, and 2 times 16. Now, we're not just making those numbers up. If you were following along, where are those numbers coming from? Why do we say 13 times 12? There's 13 what? So the atomic mass of carbon then is what? Is 12. That's where those numbers are coming from the periodic table. Since it says C13, you take 13 times 12.01 and 18 times 18. No, that's not right. That would be 324. Taking 18 times 1, giving you 18, and then 2 times 16 for 32 for your oxygens. All of those numbers added together gives you 206.31. Okay. If the tables in a bottle contain a total of 33 grams of ibuprofen, okay, how many moles of ibuprofen are in the bottle? Okay, so just like we did in chapter 3, you're starting with an atomic mass, 33. That's the only place you can start with. And that's what they're illustrating in step A. It says you're changing grams to moles. Okay, so if you turn the page to 242, okay, where it says compute, you're taking 33 grams of ibuprofen and dividing that by 206. The grams cancel each other out, and that gives you the number of moles. And that's what the question was asking for. How many moles are in 33 grams of that substance? Okay. Then in letter B, it's asking how many molecules of ibuprofen are in that bottle. Okay? Yeah, I'll take it right there. Okay. Awesome. Thank you. So when we're talking about particles, okay, I believe that's what, or molecules, I think. We're dealing with atoms, molecules, particles. That's Avogadro's number. So you're eventually going to take that number times what? From chapter 3. .022 times 10 to the 23rd. That's right. Okay. Now, in letter C, okay, that's where we're going to apply this information here. But I prefer that we start from the beginning. So I'm going to turn back to page 241 so you can see this process all the way through. Is this a yawn or what? That's what I thought I heard. Oh, okay. Oh, just all right. Well, I'm sorry. We're trying. Not doing a very good job, but we're trying. So, okay. What is the total mass in grams of 33 grams of ibuprofen? So we want to know if you had a pill of ibuprofen that weighed 33 grams. We want to know of that 33 gram tablet, how much of that is carbon? That's what you're illustrating in this problem. The reason this is so important is this is going to start to set, what I want to say, the stage or the precursor for what stoichiometry is. Okay? And to me, in my opinion, that is, and I think a lot of people would agree, that's the entire backbone. In other words, what makes up the biggest part of what inorganic chemistry is, and that's stoichiometry. Because you're taking everything that you would learn, writing out compounds, balancing chemical reactions, changing one substance to another. And here's the first stage that we're going to set for that success, we hope. Okay, so it's saying you've got 33 grams of that ibuprofen. Okay? So I'm just going to put IBP for ibuprofen. Don't really feel like writing all that out. C13, H18, O2, that's what ibuprofen is. Okay? So, again, what we're looking for is we want just the amount of carbon in there. Okay? So, the answer is not 12. The answer is not 13. Okay? Because we've got this small tablet that was 33 grams in size. But how much of that tablet is composed of carbon? And that's what we're going to compute or figure out here. Okay, so we've got grams, and we want to cancel that out. So in our next step, where would grams go? Okay, so for every, what's the atomic mass or molar mass of ibuprofen? besides knowing that, telling you that in the problem, how would you figure that out? You would add all these together. We illustrated that as well. So 206, is there a decimal point? 0.31 grams for every one what? For every mole of ibuprofen. Okay? So what happens to these grams here? Well, yeah, you're dividing, but we're not done with this problem yet. But what happens to this factor label is what I'm saying. Yeah, they cancel each other out. Okay? So, now, we're only in moles of ibuprofen, but what is it that we're looking for? The amount of what? Amount of carbon. Okay? So, one of the things, we're going to go two steps further. I said one. Excuse me, I meant two. So, how would we cancel that mole of ibuprofen out in our next step, do you think? We're going to put it on the bottom. A mole of ibuprofen. And this is the two steps, okay, that is you're going to be utilizing a lot from here until the end of March. All right? So, again, we want just carbon. This is moles of this entire substance. So, we want just carbon. So we would put that, just the amount of what we're looking for there, because you correctly identified what do these two factor labels do. They'll cancel each other out. Okay? Now we're on the home stretch, because it asked, what is the total mass in grams of carbon? So we've changed the entire molar mass of ibuprofen all the way down to just carbon. Okay? We've done that mathematically. So, how do we get the moles of carbon to cancel in our next step? Put it on the bottom. Then, what is the molar mass of just carbon? Because we have the molar mass of ibuprofen, but we want just the molar mass of carbon, which would be what? No. You're trying to put two steps into one. 12. Okay? Now, the author goes on to state the answer you should get is 25. Okay? So what happens if you, because this is incorrect right now. You don't have to erase anything if you have you don't have to erase anything if you have written this down. But if you multiply what we have down right now, it's going to be incorrect. Okay? And here's why. Because you had said something about what, 120, okay? And you did that by taking 12 times what? Now, can you do it that way? Yes, but I would advise not doing it that way. The reason I said you're putting two steps into one, that's fine. But when we go back to our formula, what's the little subscript for carbon? How many do we have in ibuprofen? 13. So that is how you came up with that big number, and you put it here. But this is how we're going to approach this. Okay? So again, what Noah is saying, if you take 12.01 times 13, okay, you'd have 156 here. But you're getting the same answer, but you're going back to this formula. And that's where that 13 comes from. And that's why we, the author, and that's the way that I'm teaching you to do this. This is how we're doing it. If you want to put this 156 here, I mean, that's fine, but you got to go back to the formula anyway. Is anyone confused with that step? Left outside on the bus. Left middle. Middle. Right middle. Right outside. Okay? So, once you punch all these numbers out, do you get 25? Or are you just saying, wow, that's what we should get? Well, let's go ahead and take 33 times 13 times 12.01. That gives us 5152. 5152. But we got the bottom to go yet, which is 206. And we get 24.97. 206.31 equals about 25 grams. Okay. So up to this point, this is all review. I mean, review from a long time ago. I get that. Okay. Probably August and into September. Yeah. So this information's is new. But if we stopped here and went this direction, that's a review, but we're taking two concepts and putting them into one. The reason we say that is we were, up to this point, we were just concerned about how many moles are in this compound. Now we're talking about an entirely different compound with just one element in there. We want to know what that's composed of. So taking this 33 grams of this whole substance, well, how much of that is carbon? And that's what you're mathematically doing right here. Okay, so still, left outside, are we good? Left middle, middle, right middle, right outside. Okay? Can I erase this? Okay. So, purple or blue? Okay. So, does someone want to come up here and illustrate how to do this? Okay. But we just erased this, said we understood this. Well, this is the same concept, though. No? We're good? No? All right. Somebody else? Oh. Well, see, I bring these up probably because it's so boring listening to me. That's why I'm giving you the chance to listen to somebody else. But look at it from my point of view. Okay, can we take time for that? Look at it from my point of view. We just went through and shown, I get it, it's just one example. And we asked all the way across, we get it, we get it, we get it. Okay, so if that's the case, should we be able to replicate that same type of information but with a different compound? Okay, so that's from my point of view. Okay, so how about we knock it out then? Yeah. One, two. I see two people working at it. But see, we just asked that. We said we understand this. That's why I'm kind of confused here. How about you point us in the right direction? You tell me what to do. How do we start that? Well, from prior knowledge, what's silver nitrate? Okay, Ag. Now, of these two ions, what should you start with? Did we say you should start with first? With the metal? No. You can, but this is kind of an exception. We always said go by your negative ion. Okay? So nitrate has a charge of negative what? -1. Silver has a charge of what? Those charges add up to 0. So therefore, you're done then. Okay? So how many grams of silver, so just of this substance, okay, are found in 260 grams of this entire compound of silver nitrate? Okay? So we've got 260 grams of silver nitrate. Or if you just want to write AgNO3, that's fine. Okay? So how do we get this grams of silver nitrate to cancel in our next step? Okay? So we got grams on the bottom. Grams of what, though, specifically? Okay? And then what would go on top? A mole of what, though? Silver nitrate. Okay? So we left room here because we need to do what with that AgNO3? The atomic masses. That's right. Okay. It's somewhere around here, about 170. Okay. Okay. Is anyone confused where this number came from? Atomic mass of silver is what? About 107? 107 plus 14 plus how much for all those oxygens? 16, 16, and 16 is 48. All of them added together gives you 170. Now, remember, we're just in moles of silver nitrate. We want just silver. So, what this step allows you to do, it's called mole ratio really, is cancel the substance that you have, which is silver nitrate. So in our next step, if we want this to cancel, where does that have to go in our next step? On the bottom. Okay? Now, this is what we have. What is it that we're looking for? We must have underlined this for a reason. We just want what? We just want silver only. So, for every mole of silver nitrate, we would put moles of silver on top, because this step allows us to change what we have, which is the entire compound of silver nitrate, into just silver only. Okay? Now, these are gone, so we're getting closer. How do we get rid of that mole of silver now? Okay? So if we put a mole of silver on the bottom, what would we put up on top? What are we looking for? In grams of silver, which is approximately, again, is it 107 point, I don't know. Okay. Now, Unlike the last problem, we had to go back to the formula and put in a coefficient from the formula. Now, how many moles, according to this formula, is silver? And we've got 1. But if this had said how many grams of oxygen, if it said how many grams of oxygen, this would be 16, but going back to our formula, what would we write here? You're correct. Where'd you come up with the 3 from? Because you got 3 in this formula. Okay, and that's right. So now everything's canceled. You're into grams of silver, and that's what we're looking for. Okay. So in this case, we'll take 260 times 107.86 and divide that by 170. We get 164.96. Okay, 164.96 grams of silver. Now, maybe an organic or an inorganic chemist might be interested in doing a breakdown of, I don't know, Gatorade or maybe different types of dietary pills and looking at the iron content, the manganese, the zinc, any one of those ions inside of that to see, well, the recommended daily allowance is maybe 50 milligrams. I don't know, I just made that number up. Okay, so that's maybe an application that I don't think it would be calculated by this anymore, but one of the things that the approach that we take later on in this chapter is, for instance, you are all going to be forensic scientists. Dr. whatever, Dr. Lee, or Dr. Johansson, or Dr. Miles, or Dr. whoever. You've got your PhD in chemistry. Okay? So, if one of the examples we gave, something about a shovel from last week, right? Was that you? Okay? And unfortunately, you too. Well, I shouldn't say unfortunately, but, okay? So, we got a disgruntled customer back here. We got a shovel laying around. So, whap, right in the back of the head. And it caused a contusion, which is a fancy way of saying a bruise. And when things bruise in the human body, how can you tell that? It's the color, right? What color do you notice? Right. All the different colors, because what's starting to form or pool underneath the skin? Well, in the cranial region, why is that a problem? Right, that's true. But as that blood, it continues to pool and pool and pool, does it have anywhere to go? No. It's going to start pushing down. Pushing down on that individual's brain. One, it'll probably cut the blood supply off, because if you have a blood vessel going through your different ventricles or parts of your brain, the more pressure you put on that nice sphere, it gets crushed. Okay? So once you start losing nutrients to your brain, it's just, it's lights out. I mean, so now, Dr. whoever in here, come across this scene, they're going to take a swab of that. Okay? And once they've taken that swab, now they got to find something to compare that to. This angry person, that shovel's got a kind of funny tint or color, and it's got a big dent in it too. Well, him and the victim here had an argument, so we're going to get a warrant. We're going to take a look at that shovel. Okay? And maybe it's a chemical breakdown of what you find in here and a chemical breakdown on what's on that shovel. And if they match, now you found the weapon that you're looking for. So a computer would do this. You put in a gas chromatograph or a mass spectrometer and it says, well, it's got 164 grams. But your job now as this forensic scientist and being a witness on the stand is you're explaining how this process actually works, because that's what a professional, well, I shouldn't say a professional witness would do, but you're explaining what's actually happening. Okay, we got this compound that we found on both of the shovels. We put it in this mass spectrometer, and what it does is it takes a look at the entire compound and just breaks it down into the individual components. The individual components in this case are silver, nitrogen, and oxygen. So when you do that, you need to be able to explain that effectively and efficiently to the jury. Because, who's our DA in here? Okay, you can pick the DA in here. Who's the district attorney? So Lane, he's going to make sure that he gets him nailed to the wall. Cole, are you in trouble? Oh, okay. You didn't do it. Now you're going after him. Okay. So it could be relying on your testimony on if this is correct or not, to effectively explain that to the jury. That's just an example. Yes, I get that. For instance, the computer is going to do all the work, but you have to be able to communicate that scientifically. Okay. So, does everyone have this question wrote down? Okay. Did I say the one in the blue? Yeah. You have the one in the blue wrote down. Okay. Can I erase that top one? Okay. We'll go ahead and start with this bottom one tomorrow then. All right. So, what? All right. So, if you were a good guesser, and maybe you are, or if you were a betting person, somebody may be off by a factor of 2. And it's a perfect 2. Well, what are we dealing with? What is sulfuric acid? The formula for that. So what's significant about that hydrogen? It's got what after it? If you're off by a factor of 2, someone may have forgot to double that. Yeah. All right. So we'll start with this. Tomorrow we'll catch up to you next time.